Bonjour à tous, bienvenue à l'atelier donc, que nous organisons avec l'équipe d'implémentation de la SNOMED internationale, donc avec Anne Oyen, Kay Quilly et Alejandro Orsonio. Je vais donner la parole à Thomas qui va vous présenter en fait les règles de bonne pratique pour cet atelier, ce qui est sous forme de webinaire.
Bonjour à tous. Alors, pour cet atelier, quelques petites recommandations pour son bon déroulé. Premièrement, vous avez bien sûr l'espace conversation dans lequel vous pouvez échanger avec les intervenants. Mais si vous avez des questions, on vous recommande chaleureusement d'utiliser l'espace Q&A parce que ça nous permet ensuite de faire des exports, de garder une trace de vos questions et de pouvoir enrichir voilà, les réponses qu'on peut vous apporter. Ensuite, les micros et les caméras sont pour le moment désactivés. Voilà, mais si besoin, au cours de la présentation, je reviendrai les réactiver pour tout le monde, pour que vous puissiez poser vos questions. Et voilà, et enfin, la séance est enregistrée. Voilà, donc le replay sera certainement publié sur le site de l'ANS et la page YouTube. Voilà.
Merci Thomas. Donc voilà, maintenant je donne la parole à Anne et Kay pour vous parler de la SNOMED CT. Elle est un petit peu, même beaucoup plus profondément en fait dans l'utilisation notamment des requêtes SQL et sur tout ce qui touche à la modélisation. So Anne, the floor is yours.
Thank you very much. I was assuming that was what you were saying. Thank you, Elizabeth. I will just share my screen. So, do you see a presentation?
Oui.
Good. So, hello, everyone. Very nice to meet you all virtually. My name is Anne Randolph-Høyen, and I will be doing this session today with my colleague Kai Kuehli. Before we introduce ourselves, I'll just show you this outline of the program that we have planned for today. So we are starting with what we are doing now, the welcoming and the introductions. Then I will give a presentation on SNOMED in the information models. And we know that we'll jump directly into the key details of what it takes to implement SNOMED CT. So if some of you haven't been introduced to SNOMED CT before, please don't hesitate to ask questions. And otherwise, we'll point you to some resources where you can go afterwards to get some background knowledge on SNOMED. So feel free to ask questions if there are something that you're thinking about as we go along. The presentation will also include some demonstrations and examples to make it real and to really show so that we can show the principles that we teach here today. At 12:30, we're going to have a break for around 30 minutes. And after the break, it will be even more technical than it is in the beginning, because Kai will come in and he will talk about FHIR terminology services and SNOMED, and we'll talk about the role of a terminology server and the features of a terminology server. And at 3 o'clock, around 3 o'clock, we will end the session with some time for questions and discussions at the end. So we hope that sounds good to you. And now I'll just go. So who are we? So we come from SNOMED International, which is the organization that maintains and distributes and owns SNOMED CT. And we own, when I say own, it's actually our members. I think it's around 51 members, where each member is a country. And France is, we are very pleased to have France as one of our members at SNOMED International. The three of us on the picture here is myself, Anne Høyen, Kai Kuehli, my colleague Kai Kuehli, who you also see online. And then we have a third member of our team, which is Alejandro Lopez Osornio. He lives in South America, so he's still sleeping, and we didn't want to bring him out of the bed too early. So we will run this today. But if you get in touch with us, you may also get some responses from Alejandro. The implementation support team is just one out of many teams at SNOMED International. We have authoring teams or content teams. We have technical teams, education teams, a variety of teams working to provide the services to suit members and affiliates. But the goal of our team is to collaborate with you as implementers of SNOMED CT to actually help you achieve your goals and the meet your requirements for SNOMED CT. So we are here to help you, and that's why we really hope that you will reach out to us if you have any questions today or later on when you work with SNOMED CT. I come from Denmark. I have a background as my biomedical engineer, and I've been working with SNOMED CT for many years, both within research, education, and as an implementer and implementation specialist. Kai, do you want to introduce yourself?
Yeah, thanks, Hannah. Hi, my name's Kai Keeley. I live in the UK. I've been with SNOMED International for about 10 years. I was working in the technical team for a long time. I've got a software engineering background. I was the technical architect of the authoring platform, creator of the Snowstorm terminology server. But now I've left the technical team and I'm really enjoying being in the implementation team and working more closely with all of you. Thanks, Hannah.
Just want to before we start, point you to this webpage, which is our portal, the implementation support teams. And on this website, you will find a lot of information relating to the implementation, the kinds of services that we have, the tools that exist to support SNOMED, and different aspects of implementation. This is also where you'll find links to many of the resources that you will be pointed towards during the session today. So the implementation support tool is this one. We also have a range of education offerings, which are free to you because you are based in a member country. So we have a variety of courses. To start out with, I would recommend the foundation course, which gives you a very good background knowledge and foundational knowledge on SNOMED CT. And when you have done that, I would recommend that you advance to the implementation course, which is more than a course. It's actually also a big repository of learning resources focuses on specific topic areas. So if you're interested in decision support, you can take a module on decision support. If you're interested in understanding how to query and analyze data using SNOMED, you can take a module on that, and so forth. There are also modules focusing on the various techniques that you apply to implement SNOMED CT. So the implementation course is also very interactive, so it includes a range of exercises. So I would advise you to take a look at our course or education catalog here. So it's time to get started now with the first topic on our agenda, which is the presentation on SNOMED and the information models. We have the chat, the ability to write chats here. So if you want to just raise your question, do it just in the chat here. We'll make sure to monitor it, and we'll pause on the way so that we can have a discussion. So I can see that many of you already found the chat feature. So bonjour to all of you, and let's now get started. So we've called this presentation SNOMED and the information model. Even though SNOMED CT is one of the key resources to achieve semantic interoperability and high quality clinical data, SNOMED CT is just one brick of the puzzle in the whole e-health data space. And you need to understand how to apply it properly. And to do that, it requires it to be bound to an information model. So one of the key elements of an implementation of SNOMED is to be aware of how SNOMED CT fits with the information model that you are using. So this is why this is one of the key aspects of implementing. It's in the boundary between what is pure technical and what is more informatical. But this is one of the foundation principles that you should know, even irrespective of where you are and what your role is when you implement SNOMED CT. The outline for this presentation is, as you see it here, we'll talk about terminology binding. That's what it's called when you link SNOMED CT to the information model that you're working with. We'll talk about why this is so important and what makes it difficult. And then I'll give you some pointers and some principles to follow when you start to implement SNOMED CT to do it properly. And in that whole presentation, there's a range of different aspects, such as how do you apply a subset, what is a subset compared to a value set, what is expression constraints when it comes to SNOMED CT, and what is the role of that when we talk about terminology binding. And then we'll talk about the concept model, which is a specific term we use to talk about the rules that we use to define SNOMED CT concepts. Then I'll give a few examples at the end and a demonstration of proper terminology binding. So when you start to introduce IT within healthcare, you have a lot of ideas about why this is important and what you want to obtain. I'm sure that you could all list this long list of anticipated benefits of introducing an IT system within healthcare. It will help us to be more efficient in the way that we document and share information. We can capture data very accurately. We will have it just by hand because we have the computers everywhere, so we can just look it up and see the information. We can share data across the various stakeholders involved with caring and treating patients. It will therefore also enhance patient care because we will have that real-time access to information. And because we now have clinical data, we have a better foundation to do analytics and decision making. Maybe we can introduce decision support systems. So that's just some of those benefits that we all talk about when we talk about implementing health IT. But the fact is that it doesn't come that easy. It really requires a lot of effort and a lot of good thinking to how is it that we can actually implement IT systems and use standards to achieve these benefits. So have that in mind as we go through this presentation, because that's the point of everything that we work with here is how is it that these benefits can actually become a reality. One mistake that is often made when you start to introduce an IT system within a healthcare setting that has been used to using papers or more analog IT, not IT, but paper-based records. That is that you take that piece of paper, maybe it's a clinical form where you document things and you follow a certain structure. Maybe you have some fields where you can check it off if it's a question. And often when you then start to design, you show them that paper and say, well, we want the user interface to look something like that. And then you end up with a system where you have the exact same fields and terms. And that is very convenient for the clinician. It increases the recognizability. And that is very good. They can recognize the terms. They can more fastly adapt to that change in the way of working, because what they see on the screen is very reflective of what they are used to working with. The problem is that if you just do that, plug electricity to your paper, if I can say it in that way, then you will not have been thinking about, well, is this the right way to do it in terms of how we're going to use this data afterwards and all these goals we want to achieve? If I have just hard-coded my codes and values and everything, I really have not a good foundation to support interoperability and secondary use of data. Therefore, you need to think about, can I do this more standardized and more holistic? Can I look at what are our goals? What are our environments? what are dependencies, and often standards will help you to really realize interoperability. When we talk about standardizations, there are many aspects of standardization when we talk about IT systems. But for this part, for the semantic interoperability aspects, there are two key components, being the terminology and being the information model. So that's what we'll focus on in this presentation. So there are other standards as well, but these two are the elements that relate to SNOMED CT and how you build the systems. The terminology in general, not just SNOMED, but any terminology is a vocabulary associated with a certain field of study. SNOMED is a clinical terminology, so it focuses on the clinical domain. We could also have a terminology about birds or food or other things, but a terminology in general focuses on the terms that are used within a specific domain. So a clinical terminology serves to provide a systematized and controlled vocabulary of all the phrases that can be used during the process of caring and treating of a patient. So all the information that you would want to capture in and around a health record. And you may want to, and you want that clinical vocabulary to support very precise and shareable expressions so that you can actually compare and achieve as accurate a result as you would do if you were using free text. So that's what the terminology is. The information model are more about the models that are used and the objects that are used at a conceptual level. So independent of what protocol you use to transport the data or any other things, it's about the structures and the objects that you are trying to represent. So let's dive a bit more into each of these. And first now look at SNOMED CT. SNOMED CT is the world's most comprehensive clinical terminology. It includes more than 350,000 unique clinical concepts. So before I talked about phrases and things that you would want to capture in and around a health record, SNOMED CT includes more than 350,000 of these different clinical entities that you would want to capture. And all of these concepts, we call them concepts, they are bound together or linked together through relationships, semantic relationships. And for each concept, you can also have a set of descriptions. So I may call a pneumonia a lung infection. It doesn't really matter because the meaning is the same. So we want to support the human spoken language by connecting the range of terms that is relevant for a concept to be linked to that concept. So here you see an example with myocardia, in fact, and some different descriptions to represent that concept. So because we have the concepts, we have the descriptions that are used to name the concepts, and then we have all these relationships. SNOMED CT become this huge semantic network. That's actually the concepts and relationships that make sure that we have this huge network. So if you have been used with working with statistical classifications, you may think of a terminology as a list, a nested list with hierarchies. SNOMED CT has hierarchies, but you should think of that more as a big cloud or a big graph network of concepts that are linked together through relationships. Let's look a bit more at the relationships. The concepts themselves, they are just a number that represents a unique clinical idea. So this concept we have here representing myocardial infarction, that has a code, the concept ID, which you see here. 222-98006. It's not something you can remember. So the concepts or the concept identifiers are not intended for humans to remember. So you should just use the descriptions that are associated with that concept. Those codes are only for the computers. So for that concept, which we could also call heart attack, we define that through relationships. We have here the relationship between the concept heart attack to ischemic heart disease. And the type of relationship is that it's an ISA. So a heart attack is an ischemic heart disease. It's also a myocardial necrosis. Then you see a third type of relationship, which is an associated morphology. So this relationship speaks about the morphology of the heart attack. And in this case, that is the type of infarct. Then you see a fourth or third relationship type called the finding site. And that type of relationship is associating the heart attack to the cardiac muscle. So you can see that these different types of relationships, they are actually semantic relationships. So the nature of the relationships is helping us define a certain property of that concept, that it's is the source of that relationship. So all the concepts in SNOMED, those 350,000, or at least many of them, are defined using these relationships, so that through the relationships you can actually start to understand the meaning of the how that concept is defined. So that is the defining properties. These ISA relationships are special. They are used to form a subtype hierarchy. So that is related, that is comparable to those hierarchies that you will have in a statistical classification. The difference is that you can always be sure that these ISA relationships means that the child concept is a true subtype of the parent concept. In SNOMED, we have 19 top-level hierarchies, and here you see an overview. So it spans from not only being relating to procedures and diagnosis. No, we have hierarchies relating to body structures, to physical objects, pharmaceutical, biological products, substances. We have a range of different hierarchies as you see them here. And that is required because, as I said before, we want to support all the information that can be captured in and around a health record. And that includes signs, symptoms, tests and test results, general observations of a patient, history, social circumstances, and all of the things that you see here on the slides. And that is why we have such a broad scope of hierarchies in SNOMED CT, because you can use one single terminology to represent all of this information within your health record. So you don't have to use 3 or 4 or 5 different code systems, and you don't have to invent your own. When you have the services established to work with SNOMED CT, you actually have a very, very good high quality foundation for your data capture and data use in your system. This is how much you'll get off of an introduction to SNOMED CT in this presentation. So for those of you who have not heard about SNOMED CT before, will assume that this was very fast and there's many questions that you may have. So please feel free to jump in with your questions, and otherwise look at the foundation course as I was showing you before. Now, let's go into the other part of those keys to proper terminology binding, which is the information model, and about the objects that you used within the healthcare environment or IT environment that you're working with. When I first started to learn about information model, it was a bit confusing to me, because sometimes we spoke about data capture, other times we spoke about communication, other times we spoke about how we store information. So I think for those of you who are not familiar with information models, it's important to just know that this is an umbrella term that we used to speak about the different models that we used for various purposes. So this slide gives an overview of some of the information models that are used within healthcare. So over here you can see what we've called some of the system core models, those that models of use, which would be a user interface model, that in this user interface we want these 3 data entry controls of these types bound to these value sets. It could also be an storage model. Think about an ER diagram where you speak about what are the entities we have and the relationships between our entities in our data storage. Models of meanings are more abstract. in that it can be like a clinical model nationally or regionally or internationally, saying these are the terms that we use for within nursing or nutrition care, or it could be for obstetrics, something where you have some models that you to describe and to harmonize the things that you do within certain fields. Communication models is about when we forward and communicate information or exchange information between different organizations, how does the message look like? What are the metadata required to properly understand it? And how do we make sure that all the information that we want to forward is actually represented in those models? And you can also have data warehouse models that you use for analytics and other knowledge models that are more related to representing the clinical knowledge within the clinical domains, including decision support, rules, and so forth. So you can see information models is a broad thing. And in this presentation, I want to just use one of these as an example, which is also relating to the topic of today, which is FHIR. So FHIR is one of the types of information models that you will work with especially if you're using FHIR to communicate with other organizations within your country. FHIR includes a set of resources, again, focused on health sharing of health information. And one of these resources is the patient resource, as you see it here. So when we spoke about the general definition of an information model, we spoke about objects. So for a patient, when you want to represent information about a patient, this resource will say, what are the things that we can say about this object or this resource, a patient? Well, it could be that the patient has an identifier, a name. Let's go down the list here, a gender, a birth date, an address, a marital status. So these elements that are included in the patient resources all represent an attribute that is used to describe that specific patient. And you can also see this resource comes with cardinality. So, for example, you can only have one birth date. You can have many general practitioners, and that is probably specific to a certain country or territory, but you can then also create these guides to specify, well, in this context, you may only have one. So this is the general patient resource as you see it, and there are links to other resources in FHIR. But you use this as the standard for when you receive information or when we communicate information, these are the things that we can or shall communicate. Another resource is or an object that is represented here is the problem, and that's through the condition resource. And again, if you have a condition, you can see that there are different elements that you can use to describe this condition or problem. There can be a status of the actual condition, a verification status, a category, a severity, the actual code of the condition, the body site that it relates to, and a range of other different attributes or properties for that specific condition. And another thing that is important with these is that, of course, it comes with a standard format so that we know what format to expect and what things to, where to find the various things within that format. When you look at the FHIR, the different FHIR definitions, the FHIR resource definitions, you can see here when you go into the FHIR HL7 FHIR site, that when you look at these, some of them will be codable concepts. So you will look at this type field here, and you can see that some of these are codable concepts. And these codable concepts are where SNOMED becomes relevant, because a SNOMED CT concept or concept identifier can be used as a codable concepts when bound to a FHIR resource. And let me just show you an example of that. So here you can see this is a resource type of type condition. And then you can see that these different elements that I showed you in the model before are represented within this JSON here. And you can see the clinical status has a coding. The terminology that is used for this one is an HL7, so they come with some predefined value sets for some of their data elements. But you can see here down in the code one for this condition, the code field, you'll see that the coding for this code is that it's a SNOMED code. So this URI here is the one that we use to represent SNOMED CT in general. SNOMED International has defined a URI standard, so I can point you to that where you can see these are the URIs that we use for referring to specific versions and specific editions of SNOMED CT. And Kai will also come back to this in the afternoon where we'll talk about the different services. So we know that this is from SNOMED CT, and then under the code element within this coding, you can see the identifier. So this is the concept identifier for this concept, and the display will then be the term as it was displayed on the user interface. No, this one is the term that comes from SNOMED CT, and this is the type of term that is, we call it the fully specified name, so it includes some brackets at the end of the term. So this is the ischemic stroke, which is a kind of disorder. Then you can see that for this code, there's also a text, and that can also be derived from the descriptions associated with the concepts in SNOMED. We have some concepts that can be defined as the preferred terms. So those would be the terms that are preferred in a certain context. But you can also define your own. Maybe you have a local interface terminology and then you have created a map or something like that. So that text here would be the term that is displayed to the clinicians when the data was recorded. I'll just check if there are any questions. No? So you should, for each of these data elements that are of type codable concept, or codable concept, you can see that there are these codings. And in these codings, you can then see what are the code system it comes from and what is the actual code and the term that was used. So that was the introduction to what is the terminology and what is the information model. And now we have already started to talk about the relationship between the terminology and the information model. So this is where we talk about terminology binding, because a meaningful health record requires that the SNOMED CT is bound appropriately and consistently to the information model. You can say that, well, we have SNOMED as a big graph of all the clinical knowledge and how the different clinical entities are related. And that's super useful when we want to do analytics and querying and decision support and just accurately capture information. And the information model is a necessity when we want to make sure that when you interpret your data, there are different things that are required to gain the full picture of that situation. So these two elements are key because they really are dependent on each other. So therefore, you need to be good at terminology binding when you implement SNOMED CT. And why do you need to be good at terminology binding when you implement SNOMED CT? Why is it so important? Well, if you do proper terminology binding, you will end up with clinical data that has a higher quality because you make sure that the terms or the concepts that you actually record reflects the clinical meaning that you also want to represent. And when you do it properly, when you bind SNOMED CT to your information model, you will also obtain a faster and more accurate data input. And I argue that you will obtain a faster one, and you will see that later on. We'll show you some examples of terminology binding. But I've already told you that we have 350,000 concepts. So imagine that you said to a clinician, well, here is a bucket of 350,000 concepts. Now find the one concept that you're looking for. That is not fair. And it's not realistic that you would do that in a clinical, busy clinical day-to-day job. No, you need to design the systems where it will be very easy and fast. And SNOMED can do that very easily, as we will show you today. And then also to support interoperability so that we can easily transform between one information model and another information model. And through the defining properties of SNOMED, we can actually support easy transformation across information models so that we can support easier data exchange. So that sounds very good, but it's unfortunately not that straightforward. Because when we come to terminology binding, so you'll hear us say that often today, you need to be consistent. You need to make sure that you find the right principles for your implementation situation. Because even though the introduction that I gave make it very clear that they are distinct, a terminology has one role, the information model represents the object, where the terminology has the terms and the codes. There are overlaps between the two. The terminology is very, very strong when it comes to representing the context-free clinical entities, such as a disease, a symptom, a sign, a certain body structure, or a procedure. The information model is very strong when it comes to defining the metadata and the structures in which something should be interpreted. You will include things such as dates and times, durations, quantities, and stuff within the information model. But then we have the overlap, and that relates to context. So what is the status of this fever? Are we stating that the patient doesn't have a fever, or does the patient have a fever? Is it a severe asthma, or is it a moderate? Is it a mild? So those different contextual information where the actual context-free clinical entity is being modified a bit. That context that is super important to actually understand the data properly. That is what you can represent both in SNOMED CT, but you can also represent it in the information model. And for many years, it's been a huge debate. Should I represent it using SNOMED or the terminology, or should I represent that context in the information model? And the truth of the fact is that it's not black and white, because there are so many dependencies. And generally, we would say, well, as much as you can, you should have a robust information model. But in reality, not many of the systems includes all the contextual information that you need. And therefore, sometimes you will need the terminology to also hold some context. So that is where you need to be particularly careful when you implement. And it's not just about SNOMED, it's about every health IT system that you implement. How you represent context should really be a conscious matter, that you should be very aware of what are the principles that we apply. For example, every time we apply a negation, or every time we want to, if I want to, because this is important, because if I'm querying data and I want to find all the people that had a hypertension, we want to make sure that it's only those true instances of hypertensions, and not all the cases where we actually said absent this hypertension, or no in a field that this patient doesn't have an hypertension. So you need to be very aware of how you represent that contextual information. So let us look at an example here of how context can really modify or alter the meaning of a concept, and which is also why it's so important for you to be aware of this when you implement SNOMED. So think about a clinical concept which is in SNOMED, and it's the concept of breast cancer. And that concept, breast cancer in itself, we understand it as humans, and we will also understand it when we look at a user interface. Where this has been captured. Maybe we can see that there is a heading, as you see first here, family history, breast cancer. So the human brain will understand, well, this means that it's not the patient herself or himself that has breast cancer. It's something in the patient's family. Yes. In the second example, we have breast cancer, but it's entered in a medical history form. So we as humans would know, well, then it means that the patient have had breast cancer, but doesn't anymore. And then we can see in the last example, there is a current diagnosis of breast cancer, and we would then understand, well, now the patient has breast cancer just now when this data was recorded. So we have breast cancer, and we have 3 different uses of breast cancer. And in this case, we really need that context to actually understand what is being said. In fire, you would probably have this as a condition. The current diagnosis, you would have a condition. A medical history, it may be a medical history with a certain status, or a family history. We have fire has a completely different resource for family history conditions. So you would have a different resource for that. So even though we have a concept in SNOMED, that context is important to make sure that we understand it properly. So that's one part of the tricky part, is the context. And I just want to show you here that if you don't have that context when you forward the information, if you just think that, well, we have recorded breast cancer in our system, so we should just record that diagnosis code or concept code to the receiving system without that context, well, then you would actually end up in a situation where the receiver is very likely to interpret something wrong. So this is it's really put on made very explicit here that what you can end up with is something that is completely wrong, like in this case where the greenhouse will understand that the patient has breast cancer now because you don't have any context. So it's almost the same as guessing. So you need this shared understanding of both the terminology and the model, or the context, you can also say, when you exchange information. So SNOMED and data exchange interoperability really requires using the terminology properly with an information model and be transparent of both. I will just go back. I thought there was a slide I was missing. 2 seconds. This one. This other example, I didn't mean to jump through that, I'm sorry. But this is another example that actually adds to the complexity of this, where you can see, well, you can all, in the situation where you want to record that there is a family history of breast cancer, not only could we alter the context of breast cancer, we can also actually represent the same meaning in different ways, like you see in these examples. If you have a field where you have recorded breast cancer in a family history form, you just need that one code for breast cancer. You may also have another system where it's just a field where you can select from a variety of SNOMED codes, and maybe you select the concept that this is the family history of breast cancer. So here you have a very vague concept model. You don't really know what it's about, but the terminology itself will show you, well, it's a family history of breast cancer. So the terminology will hold that contextual information. And then in system C over here, you have actually separated information out. We have one field that represents the diagnosis or the condition, and then we have a field that represents the subject it relates to, a person in the family. So here you see, similar to the example I showed you before, one thing is that the context can alter the meaning, but context can also be represented in different ways, either in the information model or in the terminology, or maybe you can even separate it out into different fields. So this is the complexity of all of this, because if you have one hospital in Nice wanting to communicate with a hospital in Bordeaux, and they are doing this differently, how is it that we can then harmonize between them? And that's where what I was talking about here comes to play. Well, you need to agree on the model and the different bindings between the information models that you're using when you communicate between 2 systems. And then the transformation can happen on each side. let's talk a bit more about the principles for terminology binding. I showed you before that we have a range of top-level hierarchies in SNOMED CT. Top levels are the 19 you see here. And when you have a certain field in an information model, for example, diagnosis or findings, well, then you can actually omit a whole range of concepts from SNOMED CT, because these kinds of information, you will find them, all of them, in the clinical finding hierarchy. Also the results of observations. Again, if you have things like a procedure or a test or some care therapy procedures or follow-ups, then you can remove all the other noising concepts from SNOMED and only focus on those in the procedure hierarchy. And then we have the social circumstances you will find under social context. So you can see the kinds of types of information that you're capturing can be bound to specific parts of SNOMED CT. And this is a key principle when you implement SNOMED, is that you make sure that you only focus on the concepts that are relevant for that specific data element in your model. So when you bind, there are two types of bindings, and this slide shows both of them. What you see here to the left is the most common one, because you use that to actually say, well, for this specific data element, these are the values that can be held in this data element. So let's look at a very simple information model, an information model that is used to represent a fracture. And in this model, we say, well, a fracture can have a type and a location. So for the type field, we have defined a value set. So a set of values that can be bound to type. So you can see here, it can be displaced, undisplaced, open, and closed. So that is something that has been defined, that these are the 4 values that can be put into type. So that is the binding between the type field and the fracture type value set. So that is what is called a value set binding. A meaning binding is when we say, well, here is an information model, and this model is about a fracture. So when we bind this to a concept, we will say, well, this fracture, this information model relates to a fracture. And here we bind it to the concept fracture of bone in SNOMED. So this will give us some contextual information about the information model. You can also meaning bind, which is what we call this, the different data elements. So all the different attributes that we saw in the fire resource before, you can actually specify a meaning binding for those if you wanted to. So here you can see when we say that we have a type of fracture, we are actually talking about the morphology that a fracture can have. So we bind that again to a concept in SNOMED to be very explicit about the meaning of this model or model part. But this thing over here is really what will help clinical end users at the end when selecting the proper things, because they can only, for the type field, select those 4 values. A lot of animations here. So if you have a clinical user interface, you can see this has a fracture with a type and a location. So those values that you can enter here comes from this value set, whereas the actual labels here, they can be represented, or is essentially the questions are what you bind to the meanings of those questions. You use concepts for that. All right. So to summarize, when you do terminology binding, these value sets are very important. So you define value sets for the different data elements of your information model. And a value set is a set of coded values that are allowed for that data element. And you can specify those value sets in different ways. You can use a rule, or you can manually sit and define these are the values that we want here. So defining value sets is important. In SNOMED, we have easy ways to define value sets by a rule. So we define a subset of concepts in SNOMED CT. Maybe we could say, well, give me all the concepts that are types of infectious disease. And then we'll get all the concepts that are infectious disease to make sure that the things that are captured here are only the things that represents an actual infectious disease and not anything else, because that's what we want here. So you can specify rules, but it may also be that we have been through a big project maybe in our region, and we have defined we want to use these 50 values as options for some study that we are doing, maybe a research project, to be consistent. So we could have manually selected, and that's the other option. When we define value sets, we are defining a subset. So a subset is a thing that is a part of a bigger thing, and so a subset can actually function as a value set. So again, when you perform terminology binding, let the question or the meaning of the information model guide you to what are the types of value sets that you should define. For example, if it's a diagnosis, you may want to say, well, I want to use all the types of diseases. If it's a procedure, we want all the subtypes of procedure. If it's a surgical procedure, you may want to be even more specific. Give me all the things that are surgical procedures. And that is where the granularity of SNOMED CT and the polyhierarchical structure, the fact that it's a network, really comes into play, because you can be very specific about the things that you want to allow in a certain data element. And then you can ask, well, is this really necessary? Is it worth the effort? And this is an example from a study that was done actually quite many years ago now, in 2014, by Dr. Jeremy Rogers from the UK. So that was before when they just initiated SNOMED implementations nationally in the UK. They did this project where they gave clinical stakeholders in an emergency department access to the whole of SNOMED CT to record the reasons for encounter. And these are the results here. So you can see these are the search terms that clinicians performed at the emergency department. For example, a clinician could have typed high temperature. For our human brains, that makes sense. There's a patient coming into the department with a high temperature. And they would find high temperature as a result of their search. And we understand that it's because the patient probably had a fever. But in the SNOMED concept that was selected 145 times was a physical force. So the actual physical force of a high temperature. So whether it's the sun or that force comes from the human body or from the thing that you use to cook or something, it's the force that we are speaking about. It has nothing to do with the specific increased body temperature. Like another search term here is alcohol. Again, we understand, well, it's probably because there was a patient coming in with maybe an alcohol intoxication or a condition relating to alcohol. But in 747 times, they just recorded alcohol, like the substance alcohol, not just that it was a beer or from red wine or there was an alcohol intoxication. No, it's just the substance alcohol. So you can see, you may have a very good quality terminology, but it really depends on proper usage and implementation to gain value. Because if you not do it properly, and if you do it like we often say, if you put garbage in, if you design a system just as garbage, you'll also get garbage out, right? But here, it becomes very clear that then it doesn't matter if you have a high quality terminology if you then just use it without considerations of the types of concepts that you want to use. So that is one of the key take-home messages from me today to you, is that when you implement SNOMED, use some of the techniques that we show you here just to do it. Make sure that you have very well-defined value sets or subsets, because these subsets are actually all that is needed to get you a good starting point for high quality clinical data using SNOMED. And And these simple bindings requires the creations of good subsets. So as I said before, when we talk about subsets, it's a group of things that is a smaller number of the things that belong together within a group. So if you have the entire SNOMED, the subset of SNOMED that you want to use as a value set will just be a smaller number of the entire SNOMED concepts. And when you refer to SNOMED concepts in your information model, they always come from a specific version of SNOMED CT. So in France, you'll have a national edition. In Denmark, there are national editions. In Germany, there are national editions of SNOMED, because SNOMED is designed to be flexible and extendable. So you can extend it, you can add your own terms, descriptions. You can also create some specific, maybe there are national reference sets or subsets that you use nationally. But every time you refer to a SNOMED concept, you refer to a specific version. And one thing I want to mention here is that SNOMED, the international edition of SNOMED, comes with a new version every month to make sure that it evolves with the emerging clinical requirements, that it allows us to adjust and improve the terminology continuously. So we have a very robust versioning mechanism. We never delete anything in SNOMED. So you will always, even though this concept may be inactivated at some point, you will always be able to track back to understand what it meant at the point when it was captured. There are many use cases for subsets, and actually think about the diagram I showed you with the information model. You can say that there are just as many use cases as you have of those information models, because you will use these subsets within the information model, binding them to all the different data elements. So what is the difference between a value set and subsets? I've said both things. So a value set is actually a set of concept representations from one or more code systems. So you can say that a subset of SNOMED CT concepts can be used as a value set, but you can also have a value set that actually consists of, maybe there are SNOMED codes, maybe there are some ORPHANET codes or ICD codes. You can also construct value sets containing codes from various sources. The thing that makes it a value set is that it's bound to an information model data element, where a subset of things is just that subset of, or a smaller set of things belonging together from a larger set of things. I want to talk about the ways that you can create these value sets. As I said before, you can do it manually, or you can do it by using a rule. So when you do it a rule, you would specify, give me all the some things. In this case, this example here, give me all the surgical procedures, or all the disorders with the morphology of inflammation. And these rules, which are very convenient relating to what I just said, that SNOMED change over time. So when you update to a new version of SNOMED and you want to make sure that you include all the newest surgical procedures, it's very wise to use a rule to construct your subset, because then you don't have to go through all the different surgical procedures and add and remove every time. You can just rely on that rule to make sure that you get the newest available procedures. And we have a specific computable language that we use for these rules, and it's called the expression constraint language, ECL. So the expression constraint language is a computable language that can be used to define a computable rule that can be used to define a set of clinical meanings. This summarizes the features of the expression constraint language. This is one of the things that we in the implementation support team is also involved with developing. And this language actually evolves with time as we can see different use cases and requirements for it. Some of the key features are those that you see up here. those with a single less than sign and 2 consecutive single less than sign, which will actually give you all the subtypes of a certain concept in SNOMED. The 2 means that you also include the concept itself. But there are very many features supported by this language, and it will help you to construct good value sets or subsets that you can use as value sets. If you want to look at the details for this language, you can jump to this link here on the site, snomed.org/ECL. But I'll just give you a few examples. So using this expression constraint as you see it here, the single less than sign, and then this concept identifier, which is the concept identifier for excision of appendix, you can actually retrieve all the concepts from SNOMED CT that are types of excisions of appendix. In our SNOMED CT browser, we have an ECL queries tab where you can go in and then put that ECL into the text box, and you can run execute, and then you'll see the list of resulting concepts. So all the concepts that satisfy this expression constraint. Here's another example that shows some of the features of the language that you can construct something that is more advanced. So what we are retrieving here is a type of disease, and then we have a refinement where we say we only want those diseases that are defined with an associated morphology attribute. So those semantic attributes I spoke about in the beginning. But the values of that attribute should be descendants or self of fracture. So those concepts that we want to get should belong to the disease subhierarchy in SNOMED, and they should all have an associated morphology of some kind of fracture. So the value of the associated morphology should be some kind of fracture. So we can also run that in the browser, and you will see that that it will give you a set of results as well. I think this is actually a good time where I will go to the browser and show you this, because maybe you're sitting where you are and thinking, oh, is it that easy? Let us just go into the SNOMED browser, browser.snomedtools.org. I will go into the international edition. Here on the front page, you'll find the different editions, and you see also a set of extensions. Here you can see the French edition. Okay, maybe I should go into that one. I will jump into the French editions after I've done my search, because that will help me. Let us say we wanted all the different kinds of pneumonias. So I'll do a search for pneumonia here in the international edition. Then you can see there are different kinds of pneumonias, and this right-hand side of the search results will actually help me to make sure that I'm selecting something that is a disorder. I'll just jump down and see if I can find something that is not a disorder. Well, I can't. So these are all disorders. You can also, over here, you can filter, give me all the procedures that has something to do with pneumonia, and then it will do a search, constrain my search result to those. So here you can see that there are some procedures that are actually relating to pneumonia. But in this case, well, I want the disorder. And now I wanted to find all the things that are subtypes of pneumonia. I just drag this concept in, I'll apply my subtypes of symbol, and then I'll run execute. This help button over here will help you to construct these. And we also have an ECL builder, but that's for another session, I'm afraid. But you can see that we have 183 types of pneumonias in SNOMED CT. And they are shown here. You can click on it, and then you can see the definition of those concepts. Back to the presentation. That was what do you call those, Kai, when you do something you didn't plan to do? So yeah, so these are the types of concepts that the search or the ECL execution engine will look for, all the things that have an associated morphology where the value is a fracture or type hereof. This will show you that here I'm creating another type of ECL where I say, well, give me all the descendants of disease with the finding site equal to some kind kind of bone structure of tibia and associate morphology of fracture. So this will reduce or refine our subset even further to only those bone fractures that are fractures of the tibia. So we use the defining properties of the SNOMED concepts to actually be very explicit in the types of concepts we want. So that is when we derive things based on how concepts are defined. But we do also in SNOMED CT support creation of reference sets. Reference sets is actually a distribution format or a standard format for sets of references to SNOMED CT concepts. We use them to represent a map between SNOMED and other code systems. We use it to define internationally applicable reference sets or subsets, or domain specific, or in a country you can create nationally agreed subsets. And the ECL, or the expression constraint language, allows us to also extract concepts from a predefined reference set. In the international edition, at SNOMED International, we distribute a nursing activities reference sets. So we don't have a specific hierarchy in SNOMED saying these are all the nursing activities. We do have a sub-hierarchy called, I think it's care and regime therapies. And many of those are probably nursing activities, but there are probably also some that are not nursing activities. So we have predefined a set of concepts that are nursing activities. And then you can use the expression constraint language to say, well, give me all the concepts that are members of this reference set. So that very easily you can say, well, the values that are allowed here are those that are members of this reference set. So let us look at a few principles for the bindings. The important principles are those three that are shown here. You need to know what data elements are included in your information model when you perform your binding. Because do you need to create a body structure value set? Maybe, maybe not. It depends on your model. Do your model dictate that you need a body structure reference set? Do you need a value set for substances? You may or may not. It depends on your model. So you need to understand what data elements are included in your model. You need to understand the content requirements and, for example, implementation logic. Are there fields that are depending on each other? Do we need the terminology to hold certain information? Maybe information about the body structure or not. All of those, you need to understand the models very well. And then you need to ensure that the value sets actually reflect the intended clinical meaning and match the information model and content requirements. So how do you become very information model aware when you create terminology binding and knowing what data elements are included? So here are two different information models. Both of them relate to describing a fracture, as we saw before. But this information model here to the left includes both a type and a body site and a laterality. The other one just includes the type field. Okay, so how do you perform terminology binding here? Well, over here to the right, we'll just create a fracture type. So we'll include all the different types of fractures in SNOMED, that some of them have body structure, some of them may have a laterality. We just include everything. But over to the left, we want to be a bit more refined. We would create because you can't use the same value set, right? Because you need to separate the value sets. So here in the left-hand side, well, because we have a body side data element, and we know this is a fracture model, it makes sense to make sure that we include a value set for those that are actually body sites that can be fractured. Not all the body sites. It does make sense that maybe my cheek or some body organ that where you would not have a defined fracture. And I'm not a clinician here, so I'm careful about what examples to use. But a body side, you would probably not have a kidney fracture or liver fracture or things like that. So these would be bone structures, body sites that can actually be fractured. And the type would then if you had the same type subset or value set as we did in the other model, we could have something with fracture of humerus, closed fracture of hip, and open fracture of bone. So they are very diverse. Some of them include body sites and others. So imagine that you did this binding and you then said in the type field you recorded fracture of humerus or fracture of hip. And then in the body site field you selected bone structure of femur. Then you will start to support or enable that you can actually start record something that is nonsense, doesn't make sense. You've just recorded fracture of humerus, then you shouldn't be able to select femur as the body site. So this relates to that you need to know the dependencies, and you can use the ECL language, the expression constraint language, to actually construct value sets where you make sure that the fracture type doesn't include any body references to any body structure. Or you can implement some logic to say, well, if I have recorded a body or a fracture type that includes a body site, then I will pre-populate that specific body structure in the body structure field so that I validate that it's pre-populated, so I don't have to select that. And that can be done. Because we want essentially to make sure that that logic is embedded in the system to give the clinicians an easier data entry process and make sure that they don't make mistakes or supporting them in that. Yeah, this shows that this is how the fracture type subset could look if you omit all the body sites. Open fracture of bone, a closed fracture of bone, and a compression fracture. You don't specify specifically what bone it is, but you just say something about the type. So that's one of the decisions you need to make when you perform these types of binding is how do you ensure that or support that you don't end up in a situation where you can enter information incorrectly. In this case, then you would have the body site, including the different bone structures. So then there is another principle, which is about ensuring that the subset reflects the intended clinical meaning. For example, if you have an observation, we have a hierarchy in SNOMED, including all the different observations you can do. And if you want to, for example, create, in this case, a subset of procedures, and you do a search for blood pressure, you'll find a number of different concepts. You'll, for example, find these concepts, but you would never use that as a procedure because it represents the observation that you're observing the blood pressure. Then you can have a blood pressure taking procedure concept that would also be found, and that would be okay to use. Whereas this concept to the right here represents the actual finding, the results of taking the blood pressure. And that means that you need to, and that the point of this one is that you make sure that the concepts that you select for your value set are actually representing the type of content that you want. Because this is the key to, when you remember the study from the UK, this is what they didn't do. They hadn't bound it to specific hierarchies or types of information. So even though the term looked very understandable for that context, the actual meaning and where it belonged in the terminology was incorrect. This one is about grouper concepts, and I don't think this is not the main point of this presentation, but there are some concepts in SNOMED CT that are groupers. And this is where a good search engine will actually help you to make sure that you don't select a grouper. For example, finding of eating ability. That's not the result of an observation. It's just a finding that represents a grouper for all the different kinds of eating ability that exist. I see that you're on.
Yeah, I just wanted to give you a heads up that we've got about 15 minutes till the break, and it's about 10 slides until the UI example, so looking good.
I will make it good. Yeah, so let's not talk too much about groupers. I just want, when I know that Maëlle and Elisabeth has translated these slides for you into French, and I want to point your attention to slide number 60 in the slide deck, or some roughly around 60. I've added a few since the version that you have received. But this one is actually just a cheat sheet, you can call it, to guide you in the direction of if you have, for example, a problem list, where in SNOMED CT should you find those concepts? And that would be the clinical finding hierarchy. If you have a past medical history, where would you find those? Well, you can look in the situation with explicit context hierarchy. If you have a surgical history, maybe you would use the procedure. So these are it will guide you to what hierarchies you should look in. And then it will also show you what are the hierarchies that you should just stay away from that have served a different role in SNOMED. So if you're not into all the details of SNOMED, then use this as a guiding point. The yellow ones here are more where you really need to make sure that you are aware of your information model. And that's, for example, body structures. I think we have a few examples of that. Yeah, this is an example why those yellow ones require a bit more thorough. Because if you have used a body structure of elbow in a diagnosis field, well, it doesn't tell you much. Similarly, if you have recorded a qualifier value such as mild, it will not tell you much about the diagnosis other than it's mild. The diagnosis, it will not tell you other than it belongs to the elbow. So where those concepts do make sense in an information model is when it's related to a main concept. So for example, if the diagnosis is dry skin, as we have it here, well, then the body side certainly makes sense, that it makes sense to know that it's on the skin structure of the elbow, and it's just a mild instance of dry skin. So these concepts that comes from the yellow hierarchies in this diagram, they are used to qualify and make it more precise, the things that you want to capture, but it should always be understood in the context of another concept from SNOMED. For example, a concept from one of the green hierarchies, clinical findings, procedures, and so forth. I don't want to talk too much about the concept model. This relates to how you can actually use the concept model and all the rules that we have for defining concepts to understand where the concept should come from. But I think we should leave that to another session. I actually want to show you, jump to the user interface demo. I'll just jump down. In this last part of my talk before the break, I want to show you an example of terminology binding. And I'll jump to our example user interface. So I'll go to snomed.org/UI. And then you'll get, and you can also go to this, you can wait until after I've done this demo here. So this is just an example EHR to see, because sometimes people ask us, well, how does SNOMED look? And SNOMED doesn't look in a certain way. SNOMED is just a terminology that can be embedded in whatever system. So how SNOMED looks depends on how you design your system and how well you implement it in the systems. So this demonstrator has been designed to support the demonstration purpose. All the fields here with an S are those fields that have been bound to SNOMED. You can see we have one here with all the patient details, and you have an S here. And where you have an S, you also have an I here, where you can see the binding. So this is a smoking status field. And when I open this, you can see 3 options: never smoked tobacco, smoker, and ex-smoker. So those who have developed this system has predefined a value set of 3 values saying, I want these 3 concepts. And those 3 concepts, we can see them here. It's lifetime non-smoker, current smoker, or former smoker. So you can click here to understand the bindings. And if I go to the encounter field, you can see that the reason for encounter has been bound to a range of hierarchies. It has been bound to all the descendants of clinical finding, or procedure, or situations, or events. There can be many reasons why you have an encounter. It could be that you have fallen from a ladder. It could be that you have hypertension or some severe asthmatic reaction. It can be anything, or post-procedure incidents. So there can be many reasons. But in the diagnosis field, you can see that we have only allowed you to record all the subtypes of clinical finding. So that's a more narrow or constrained input field. And the procedure field has been bound to all the descendants of procedure. So let us just try, let me just try to show you how this works. And this is also a hook over to the presentation that we'll have after lunch, which is on terminology servers, because what you can see up here is the terminology server that is used by this UI. And this is our Snowstorm terminology server, which includes the FHIR API, the FHIR Terminology Services API. We also have another terminology server that we could select here, which is the Onto server, which is developed by CSIRO in Australia. And they also have the FHIR API supported. So we can actually just swap between the two. You can try that out. Because they apply the same API, we can connect to whatever server. In this case, I'll use the Snowstorm and I'll do a search for, let's say this patient that we're recording data about has an appendicitis. I'll start to just type and it will just, as soon as I start to type, it will start to do the lookups and do the searches that matches my search string. And you'll see I can find appendicitis. It will show the thing that matches my search first. If I try to type appendicitis here, you'll see it's the same thing that I'm typing, but I'm getting a different result. And that's because we have bounded to specific, to different value sets, where our value sets have been defined by that expression constraint. So in this case, I can only select appendectomy, which is very suitable because I want to type a procedure in the procedure field. Again, if I was typing appendectomy up here, you can see that I get an option, but it's dehiscence of appendectomy wound. So it's actually a clinical finding. So let us instead try something else, because you can see that there's also a laterality field. So let us say that we were performing a procedure, which would be the excision. Yeah, let's take the appendectomy again, just to make this point clear. When I type in appendectomy, I can't specify a laterality. So an appendectomy is an excision of the appendix structure, and we don't have a left and a right appendix structure, nor is the appendix structure itself lateralizable. So it doesn't make sense to specify a laterality for this one. Whereas if I was recording such as a fracture of hip fracture. Let us take something else. What could it be? Excision of kidney. Kidney excision. So here you could also see that it's a word any order search. So it doesn't matter what order I do the search, it will show kidney excision, although I said excision of kidney. And now I get the laterality field enabled. I can select right or left, or right and left if it's bilateral. So why is it that I can do that? And that relates to some of the slides that I was jumping through before very fast. That relates to how we define concepts in SNOMED. So let me look up kidney excision here. I will just pick the procedure, kidney excision. And if you look at how this has been defined, it has been defined with the procedure side of kidney structure. Well, very well. If I then look at kidney structure, you can see that that has been defined with the laterality. You can also go up here and see that this concept belongs in a subset that we have defined. And this subset includes all the body structures that can be lateralized, because it's not all body structures where it makes sense to have a laterality. But those where it does make sense and where it's true that you can apply a laterality, we have put those in a reference set. And that will enable us to use the defining properties of kidney excision. So the fact that that has been linked to the kidney structure, and kidney structure belongs to the lateralizable body structure, then you can have that chain and you can use the defining properties to actually say, should that laterality field be enabled or disabled? So that is quite clever. So these were just a very quick quick look at this one. The last thing I want to show you is another example demonstrator. I'll go to an allergy demonstrator. What you'll see in the slide deck is that there are some examples and you can read through them. They should be quite self-explanatory. And what one of them is about allergies and how you record allergies. And we have a clinical reference group at SNOMED International working with discussing how SNOMED is used within the clinical domain of allergy. And they have defined this example of an information model that can be relevant for those recording information about allergies. So let us see here, you can see on the eye that I could, up here, I can specify there's a terminology binding to this, that is all the descendants of propensity to reactions to substance or propensity to something else, which I can't remember. And you can see here, if I type something in like shellfish, I get allergy to shellfish. I don't get shellfish, the substance or something else. I could also type in a nut. And you can see the different types of allergies to something with nuts. So here it becomes because it's a very constrained set and a very smaller number of concepts that are available, then I get a very fast result and I only get few options that are very, very relevant for this field. And I can then specify allergy to nut. And what you could see happened here is that then the actual substance is the nut substance. And you can see the different categories that is a food allergy has all been pre-populated. So that was what I spoke about before when we looked at the example with the fracture of bone, is that if you select a concept that has defining properties that can be pre-populated in other fields, well, just selecting one concept can actually result in a range of other fields being populated and reduce the time that it takes to capture the information. And this kinds of data entry can be recommended because it actually gives the clinician an opportunity to verify what they have selected. Yes, it is an allergy to nut, and it is a food allergy. Boom, boom, boom. Over here to the right, you can see how information can be represented in an allergy intolerance fire resource. So this will show you how the information that we have captured is used within the model. Within the clinical reference group, they have defined two different ways that are just as good. So you can also record using the propensity-based model, which is where you actually record the condition in the coding, and then you have a separate one for the substance. Another way is that you just record the substance also in the code field. So these are some of the discussions they have had on how it can be done and their recommendations. Feel free to go into this one as well. And I think I'll leave it at that. I know that was a lot of information, and after the break, we will be looking a lot more on the terminology server side. But this short demonstration here should really show how easy it was for me to just search through SNOMED CT using a FHIR terminology server. And it all comes down to you having that terminology server and you have done the proper binding. So thank you for listening.
Thank you very much, Anne and Kay. Merci beaucoup. Donc, nous allons faire une pause d'une demi-heure et on se retrouve à 13h, si vous voulez bien. Et bon appétit pour ceux qui vont manger.
Thank you again, Anne and Kai.
You're very welcome. Speak in 30 minutes.
Alors, il y a une question. En fait, c'était peut-être une erreur, parce que là, et quelqu'un avait levé la main, mais pas de question alors pour l'instant. Mais beaucoup de bon appétit. Merci beaucoup. À tout à l'heure. See you soon.
Super.
Elizabeth, I can't hear you if you're talking.
Sorry, thank you, Kay. I'm just, we can perhaps wait just 1 or 2 minutes and then.
Yeah, that's fine.
Okay.
Good idea.
Hi, Kai. Did you find something interesting in the implementation guide that I sent to you, or do you want me to find another one?
There are some body temperature sites, which are in SNOMED. I mean, any example is fine. It doesn't have to be SNOMED. I'm really talking, about the Fire API in general. I was going to look at the IPS as well. The IPS Fire Implementation Guide, if that's okay, because it's like an international one and it's kind of summary information.
Let me just check if we have something on that.
Okay.
The list of repository named implementation guide just increased day by day, so I'm losing track of what we have.
Okay.
It seems that we don't have any on that. Yeah.
I can always look at the generic
Yeah.
Fire resources anyway. They don't even specify what code system to use. They just give an example, and most of them are SNOMED.
Okay.
So as an example, it's okay.
I went to the example in the slide in the French version to just modify the URL, so it's the French endpoint. So
Okay, nice.
It should be okay.
Yeah, I think I missed a couple. Thanks.
I think we can begin if it's okay for you.
Yeah, great. It's okay with me. I'll get going then. I gotta find the right screen to share. I think you can see the slides. Yeah, I can see that you can.
Yes.
Great. I'll get going. All right. So this is going to be like a gentle walkthrough introduction to the HL7 Fire API. I'm going to assume that you don't know much about it yet, but you've probably got a technical background. Maybe you've used it a little bit. But I'm also going to talk about how specifically SNOMED can be used and some of the special features of SNOMED when we're using the Fire API. And then we'll look at some use cases and we'll look at some examples and I'll make some API requests and please ask questions as we go along. This is kind of a relaxed session. More questions is better. All right. Yeah, so I'm going to start off talking about why we should use terminology services as a tool. I mean, we could just use, flat lists of codes or have them in a database. I'm going to talk about how SNOMED and Fire work together, and we'll go through some implementation examples. Unless you distract me with lots of questions, which I don't mind, and then we'll just go that way instead. All right. So starting off, why use terminology services, a tool? You can implement healthcare systems without using terminology services. You can import all the codes directly into your EHR, for example. But we think that really good search algorithms are key for, good, effective data entry. And when the data entry is like really easy and clinicians can quickly find what they're looking for, of course, the quality of the data in your healthcare systems goes up. And that means the data is more reusable, and the whole value of your healthcare system starts increasing when the data quality is good. The terminology services allow you, a standardized way to have optimized retrieval and navigation across, many terminologies. They could be, basic terminologies like flat lists. They could be more complex terminologies like LOINC, or they could be, very hierarchical or polyhierarchy terminologies like SNOMED CT. And you can access them all in the same way and in an optimized way using terminology services. So that's one argument. You can also run queries, and that can help drive reporting, clinical decision support. Many other features are unlocked when you have terminology services available. And also terminologies are updated frequently. So the French edition, I think, is released twice a year at the moment. So getting the new edition or the new terminology or the new classification into your system is probably easier if you're using a terminology service, because it's one place where the terminology gets updated. And if the rest of the system is just using the terminology service, in theory, the rest of the system shouldn't need updating. Things should just work. That's good theory. So it's a good separation of concerns. I'm just going to touch on the kind of recommended kind of national architecture for terminology services. And we know that many countries across Europe and across the world have a national release center, and they also have a national terminology server, like Mael shared earlier, the eSante Fire server. It's a central point for the whole of France where you can access the key terminologies, the clinical terminologies that should be used in your infrastructure. But that shouldn't be the single point of failure in your infrastructure. It should really be the source of the terminology content. It's kind of where you can find it the first time and then probably take it down into your systems. And ideally you'd have another terminology server for your region, for your group of hospitals, for your city, some other terminology server which sits below the national terminology server, which you actually use at runtime to access the content, which prevents the single point of failure. And you may have more terminology content that you want to host locally, in addition to the national resources. So you can talk, obviously, to Maëlle and Elizabeth about the recommendations in France, but this is just what we recommend to all the countries. So it's worth saying as well that a terminology server can be reused by many systems. So here, for example, we've got a couple of EHRs, a PACS system, and an LIS system, all using one terminology server, probably within a hospital or a small group of hospitals. Next topic is about why use standards with the terminology services. Many terminology servers have like a custom-made API that does, kind of special things. But with terminology, why reinvent the wheel? it's good to standardize. So this is where the HL7 FHIR standard comes in. And there's one module in the FHIR standard, which is around terminology services, which is what I'm going to be focusing on today. But if you use, the FHIR standard to access terminology, it provides a standard way to do it. You should be able to swap your terminology server application, swap the backend API application without changing your client information, your client applications, like your hospital information systems, if you're using a standard API. So that prevents, vendor lock-in, for example. It makes your client systems much more reusable because they can be deployed against different terminology servers. So having this standard way of accessing SNOMED, LOINC, many other classifications and terminologies you're probably using really allows for loose coupling, and it's just good design. All right, that's my preaching over. We're going to go down a level into some more details. So, as I said, I'm kind of starting at the beginning. This is kind of what the HL7 FHIR documentation looks like if you go and look it up. There are many modules here. There's kind of some base modules about data formats. Then there's the supporting level 2 modules, and here we've got terminology, and that's what we're going to focus on for the next hour or so today. And then if we go to the higher levels, we've got the interesting ones, the clinical modules, where we record clinical information, diagnostic information, medications, and workflow and financials. So these levels leverage the terminology module heavily. Many of the the information models defined for clinical resources and diagnostics and medications have fields that are bound to a specific value set and a specific terminology. So we're going to look at some examples of that. So within this terminology module, there are 3 main resources that are available that you can access through the FHIR API. There's the code system resource, and that means it could be a whole classification, a whole terminology, basically a whole set of codes. And that's probably, some of them could be very broad. For example, an example code system is the whole of the International Edition, or the whole of the French edition, the whole of LOINC, the whole of ICD-10. So they're very broad. And they contain all the codes and all the descriptions for that code system. Next resource is a value set. This is where we've created a specific list of codes from a code system for a specific purpose. So a value set is they're the useful ones. They're more focused. And finally, we have the concept map. So concept maps allow you to translate between code systems. So maybe you've recorded your data in SNOMED, and you want to find out what's the ICD code because I want to do some, statistical reporting, or I want to, report to the World Health Organization, something like that. So we can map between SNOMED codes, ICD codes, or many other code systems, SNOMED to LOINC or backwards, or any kind of translation. So the way the functions of these resources are kind of exposed are through operations. So each resource has a set of operations. The code system provides the lookup operation, and these are operations you can run directly through the API. Lookup gives you all the information about one code in one code system, and often a code will have multiple terms, like search terms, and you can go and see them all if you use lookup. It may have multiple descriptions for different languages, In the case of SNOMED, it may have many defining relationships. I know Anna earlier was showing an example of a disorder that had a finding site of the body. It had a morphological abnormality, like a transformation in the body. All that information comes out in the lookup anyway. In a code system, we can also validate code. That's useful if you've received a code, maybe from someone else or another system, and you want to check that that code really is in the code system it says it's in. And we can also validate the terms, the display term for a code. Is this display term really included in that code system? Finally, there's the subsumes operation. This doesn't always work for all types of code system. Some types of code system have a hierarchy, and the hierarchy has a specific meaning where the descendants or the lower down codes are supposed to be subtypes. They're like specializations of the code above. And for that type of code system, and SNOMED is one of them, then the subsumes operation works. And you can test, if for a pair of codes, you can test if they have this ancestor and descendant relationship. Or maybe they're siblings and then, they don't have the ancestor-descendant relationship. Or maybe they're in completely different sub-hierarchies, like one's a substance and one's a disorder, then, subsumption won't work. So that can be useful for various tasks. Value sets have two operations. Remember, the value set is a set of concepts or a set of codes for a specific purpose. Once you've created them, you can expand them, which means list out what all the codes are. And the expand operation supports search as well. So you can list out the codes, but filter it for a specific word, for example. Validate code is available here as well. So if you've got a code and you're not sure if it should be in this field, for example, then you can use validate code to check it's in that value set. We'll show examples. Concept map only has one operation, and that's to translate. We'll show examples of all of these. Okay, so when you first approach a new terminology server, you probably want to have a look, what resources are available in that terminology server. I know the link to the eSante terminology server was posted earlier, so we could go and have a look. The standard way to list the code systems in a terminology server is through a HTTP GET operation. So you have the base of the terminology server and / code system. And then probably in a JSON response, all the code systems will be listed. Let's go and do that now. So in the eSante terminology server, it's a bit confusing. What's happening is when we go to that URL, this one here, with /fire and hit enter, we're actually redirected to Onto server. So this is the dashboard for Onto server. It's possible to list the code system this way. It's kind of a kind of web page way of doing it. I know Mail also provided the link to the API documentation. And there's a few different APIs in here, authentication. There's kind of a custom API here about listing terminologies and concepts. But if we keep scrolling down, we get to the Fire API. This is what we're talking about today. So there's a standard way of listing code systems, which is here, and it's /fire /code system. So let's run this one. Oh, something strange is happening. Okay, so you're probably familiar with this layout. This is the open API, or used to be called Swagger API documentation. And the way you use it is, you click on something that you want, gives you a bit more details, and you press execute to run it. So we're listing the code systems on the server. We get a JSON response. We can see there's 266 code system loaded. And then in the entry section, we get an array of the code systems. And there's many different types of code systems in here. They're all in French, so not that easy for me to read them. But that's the basics. And you can do this operation the same for code systems, for value sets, for concept maps. It's a standard format, just using the name of what type of resource you're trying to list. One thing to note is for SNOMED, we have both the international edition and of course we have the French edition. They will be listed as different code systems. And every time there's a new release of the French code system, that will be listed as a different code system as well. So they're really code system versions that we're listing. So yeah, you need to be careful to pick the latest one or the one you intend to use. Okay, so that's about listing resources. Now this is about actually using the resources, and our first operation is the lookup operation. So I'm going through some kind of really basic fire stuff here, and in a minute I'll get onto some of the more SNOMED specific things you can do with value sets. So our most basic kind of fire operation is code system lookup. And again, the URL has got a standardized format. We've got the resource name, and a slash, and a dollar, and then the operation name. So remember I listed all the operations at the beginning. Lookup is the first one for code system. Then after lookup, there's we add the parameters. And for lookup, there's two parameters you have to use. The first one is system, and the second one is code. So for SNOMED, the system is always this URI, snomed.info/set. This is a SNOMED code, and that will give us back, all the details of the SNOMED code. We can also specify a version parameter here to pick a specific SNOMED edition, like the French edition, and we can even pick a specific version, like a specific release of the SNOMED, French edition. With your national terminology server, it will automatically pick the French edition, and it will be the latest one that's loaded. So usually the version parameter's not needed. Later I'm going to do some examples using the public international fire server, Snowstorm. And with that one, you need to be a bit more careful and probably use the version parameter, because it has, every country's SNOMED edition loaded, and by default it uses the international, so you won't be able to see any translated content. So here's the example with the version parameter, and this version will, this is the URI that identifies the French edition. So it will give you back the French version of this code, and that will include, the translations. Yeah. So we can look up this one. Let's run this one. I'm going to come out so I can grab the URL from the notes. We're going to run this against the international fire server. I'll run it against the eSante one as well in a minute. Let's open this, see what happens. Okay, so this is our first lookup example. I realize I'm jumping around a bit. So we started off here in the eSante API documentation, and we can do lookup here as well. We can put in the concept code, the system, and the version, but I've just put it into I've put all the information into the URL here and just hit enter because it works the same. So we've got the base of the fire server, and it doesn't matter which fire server you're using. That's the point of having a standardized API, that I can run the same look up against the international server or the eSante server or another server, and the request format and the response formats are kind of the same. So we can see that this concept is myocardial infarction, and the terminology server will tell you what version of SNOMED has actually been used to give this information. And it says we're using the French edition, and we're using the June version from last year. And as I said, with lookup, a lot of information is listed. We've got the list of designations here. They're the descriptions. We've got a description in the French language, and there's many other descriptions in here as well that help with search. This is probably one of the least useful fire operations. The operations with the value sets are much more useful, I think. I'm just going to touch on the SNOMED URI standard. So we have, no single version of SNOMED contains all the codes, in all the countries and all the contexts of use. The international edition contains most of the concepts used, worldwide, but national release centers, like eSante, do distribute the international edition plus the national content as well. So we're able to use, the URI standard to reference which edition we want to select. This URI is used as, generally to say it's the SNOMED code, but we can specify which edition we want. This example is New Zealand edition, and we can even say what version. So we can say the New Zealand edition / version and then some timestamp. So it can be very specific about what we're talking about. When you're operating just within France, all the terminology servers are probably set up just with the French edition, and it doesn't matter so much. It's more like when you're receiving, if you're doing any cross-border interoperability, or you're receiving, fire messages from another country, possibly, then you might come across, these version information, and it's polite when sending, records to another country to include the version information, so they know, what version to look in to find any custom codes from France. I don't think France has many custom codes at all. I think it's just translation, but still.
Yeah, for the moment it's only translation.
Yeah, okay. All right, we're going to move away from the code system resource and look at something more interesting, which is the value sets. The value sets are really how you use terminologies. And the first operation we can do with a value set is to expand. And that lists out all the codes in the value set. And it allows you to filter them. And it allows you to display them in different languages as well. So we say the name of the resource, or the type value set, and a slash and a dollar, then the name of the operation. And then we can look at the fire documentation, for each of these operations, and it will tell you which of the parameters are mandatory and which ones are optional. But the mandatory parameters are the URL of the value set we want to use. And this is where SNOMED has got a special value set that's kind of built into terminology servers. This value set hasn't been created on the server, but it will work because this is a special URL which will essentially search the whole of SNOMED. We don't recommend doing that, and we certainly wouldn't have a field that's bound to the whole of SNOMED, for example. But it's kind of useful when you want to search for something specific, or if you're building a value set and you want to look more broadly, or it might be better just to use a browser. But as an example, this is a special URL that searches the whole of SNOMED. We can specify a display language that we want to use, and we can use a filter as well. So here I'm filtering for myo-infar, and I can expect that to find, myocardial infarction, the disorder. But because we're looking through the whole of SNOMED, we'll probably find some procedures, maybe some medications as well, related to myocardial infarction, which is the heart attack. All right, I'm going to move. Is there any questions at this point? I've been going fairly slowly, but I don't know how familiar you are already with fire. In a minute, I'm going to move on to more about value sets. I don't think there's any questions in the chat. Okay, I'll keep going. So I think Anna's already used the concept of a subset. So a subset is, a set of things, generally, usually codes in this context, that's a smaller group than the whole. So in the context of fire, we've got the code system, which contains all the codes, and then you might have a subset, which is just a set of useful codes, for a specific purpose. And in fire, the subset is represented as a value set. So an example subset might be, some findings about the body temperature. The body temperature is above the reference range or below the reference range, or it's changed, and these would be the codes. I mean, that is a subset, just a few codes. So I got no idea what this slide's about, and I didn't expect the animation. This always happens. So a subset is a way of filtering a code system for a specific purpose. Another example could be, all surgical procedures. Or another example could be a subset of all disorders with a morphology of inflammation. A morphology is like a change in the body, something that's happened to the body or one of the body structures. And the change in this instance is inflammation, so it's kind of swollen. We can do that selection with ECL. So subsets, are essential to ensure the constrained use of SNOMED and any other code system, and they can support local requirements. So use cases for subsets, of course, the obvious immediate one is constraining search and data entry. Constraining a field so that the users can only pick the codes that make sense or search for the codes that make sense. Other examples are for communication. So you could have agreed a set of codes to use when communicating with another system, or it could be, another group of hospitals within your country, or it could even be other countries. Subsets can also be used for reporting and decision support. In research, subsets can be used to specify, a group of patients of interest, or they're used in all sorts of ways, in analytics. So as I said, subsets are represented in fire as value sets. Hopefully that makes sense. Now we've got some examples of some more of these special URLs for value sets, in SNOMED. The first example is probably, the most common example in real implementations, where you've given a descriptive URI or URL for your value set, and it probably contains the domain name of someone who published it, and it may say like /value set and then some good name which talks about the purpose of the value set. And this is the way we identify value sets. But in SNOMED, we've also got some kind of special value sets that don't need to exist on the server. It's just a way of querying SNOMED, essentially. In SNOMED, there's a way to publish subsets, and it's called a ref set. And we saw one example before lunch from Anna, where she was using the lateralizable ref set. It's kind of a subset of body structures that are lateralizable. So you have like a left and a right one in your body. It probably wouldn't be the nose because you've only got one in the middle. But kidney, for example, you've got one on each side. So to reference that set of concepts, we've got this this implicit value set. We can use this URL to access the value set, and we'll get the list, even though it doesn't really exist on the server. It's there sitting in SNOMED. I'm going to run some of these in a minute so it makes more sense. There's two other examples. Another value set that's kind of implicit is the ISA value set. So this is where we can leverage the SNOMED hierarchy, and we can say, give me all the concepts that are a type of procedure or surgical procedure or anything we want. We pick a concept and we give all the descendants. Similarly, we can do the ECL queries and the SNOMED query language. So we can kind of run a query against the terminology server without actually creating a value set. I think, yeah, we've got a few examples here. So this example isn't actually going to work because I don't think the international patient summary is loaded anywhere on the server. But we could use the lateralizable ref set here. I'm going to go back actually and focus again on your use case. Let's list the value sets that you have in France on this server. We're listing value sets. Okay, there's loads and loads. I'm just going to pick the first one. So where we have the URL here of the value set, this is the way that you should access the value set. You should identify it using the URL. It's tempting to use the ID. They also have an ID here. But the ID isn't always the same. If you take this value set and put it onto a different terminology server, the ID can change. Some servers allow you to set the ID and some don't. And part of the FHIR standard is that it's up to the terminology server. It could just change it into a UUID or something else, like anything. So we always recommend that you access the value set using the URL. So I'll take the URL. It's really a URI. It's an identifier. And then we can expand the value set using this one. I've got to click try it out to unlock the fields. I've put in the URL and we can run it. Okay, so in the response, we get an expansion. We've got 11 codes, and in the contains section, we get the codes coming out and the display fields. So the display is obviously what you present to the users, and the code is what you store in the back end. Now we're going to try one of these SNOMED value sets that we're looking at. I'm going to try, don't actually know what this one is, but we're going to run it anyway. I'm taking this URL. Let's look at what code this is in the SNOMED browser, so we know what to expect. It's asthma. Okay, so this one is for all types of asthma. I'm going to run this one against your French terminology server. And again, in the URL, I'm putting this, this value set, which isn't in the list of value sets available. It doesn't really exist. It's a type of query. And it says, give me, if the concept is a type of asthma, then give it to me. Let's click run, execute. Oh, it's not working. Why is that? Usable case system with URL. Okay, because I've asked for a specific version of SNOMED. Don't need to do that. Okay, now we've got 109 codes returned. And in the contain section, we have acute asthma, many different types of asthma. So this is kind of a special feature of SNOMED, where you can use the hierarchy and expand value sets using the hierarchy. Okay, I'm going to move on. As well as expanding value sets using the URL, we can also specify the display language, which obviously you'll set FR here, and we can also filter them. So this is how, before the break, Anna showed the UI demonstrator, and the UI demonstrator is just expanding value sets. That's how it's working. So when the user types something in the fields, it essentially fills in the filter parameter. And for each field, they're already bound to a value set. So the URL is already set. And I think in the demo, most of them use the ISA filter, this one. Or they may use the ECL filter, they kind of work the same. But we're basically picking a concept like clinical finding for the conditions. And we're listing all the descendants of clinical finding, but we're filtering it by some term like appendix or appendicectomy, appendicitis in the examples we saw. So that gives us a short list of just the codes in this value set where one of the descriptions matches the filter. And in SNOMED we have multiple descriptions on each code. We've got, I should show an example of that. Let's go and look for one. When we run expand on this one earlier, we got back, oh no, I've accepted the cookies and lost my query. It's annoying. Run again. I mean, it's a bit bigger. I realize it's a bit tiny, isn't it? So when we expand this value set, we get back a code and we get back a display. And this is the term you should display to the user when you're running a search. But this concept may have many other descriptions or terms, and they can help to drive the search. So it can be confusing because sometimes you search for something and the results you get back don't match your search string. And that's because what you search for was one of the other descriptions, not the display term. So it's kind of just a gotcha, something to look out for. Okay, we talked a lot about value sets and the expand operation. If you, for you in France, there's not many reference sets that are probably very useful. We can check if we go to the international browser and go to the French edition and go to RefSet, this little tab here, and scroll down. We were looking for simple type reference sets. They're the ones that can be accessible from FHIR. And we've got the lateralizable body structure reference set, that one that helps your user interface know if the clinician should be able to enter left or right or both, or if you should just hide that field. So that one's available. But there aren't, lots of other reference sets. Some national SNOMED editions have loads and loads of different reference sets, but you guys just aren't using this mechanism. So that's probably the only useful one. That's okay. That's fine. Next example is running an ECL query using an intentional reference set. It's kind of the same thing, but we're doing /ECL and then doing some ECL query. We don't recommend using these loads. I prefer to show another example. I might jump into Postman in a minute. I'm just seeing what else is left in these slides. Okay, so this is about best practice when searching reference sets. We know that Onto server, the national terminology server that you have, and Snowstorm is another fire terminology server. It's kind of like an open source server, owned by Snowmen International. They use this best practice search where you can use multiple prefixes in any order to find concepts. And it can be useful for concepts with very long names. For example, this concept, blood oxygen pressure within reference range, you wouldn't want a clinician to spend time typing all of that, especially if they're searching in a large value set. So a good search term could be blood space, ox space within. I appreciate this is English terms, but it works the same, in French or any other language. So specifying the first few letters of many of the words should give you probably only this search result or one or two. It's a fast way to get find very specific concepts. So users who learn to use this method of multiple prefix, are doing less typing. They're finding what they want faster. And they don't need to worry too much about spelling as well, spelling mistakes and spelling issues. They can just use the prefixes. So this is kind of recommended. And it's another reason to use, terminology services, because they have this sort of thing built in. Okay, before I move on to maps, I want to jump to Postman. You probably can't see it. I'll share the other way. I'll share my whole screen. Okay, you must be able to see it now. Oh. I wonder if I can make it any bigger. Oh, I can. Nice. Okay, I'm jumping to Postman to kind of illustrate a point. We have used the eSante API documentation, and that works great, and it lists the operations you can use, and you can run them, and it all works. Another way to do the same thing using the Fire API is to use Postman. Probably many of you have used Postman before. It's kind of a standard way of making API calls to lots of different APIs. And I just wanted to show about listing value sets again. So for this collection I've got is for Snowstorm, or the Snowstorm kind of family. You can find it on GitHub under github.ihdsdo. Probably Snowstorm Lite is the best link. I'm just going to share this a minute. Not actually find the chat. Don't know if someone can send a chat message so that I can find the chat. Oh, here it is. Got it. Okay, so the reason I'm sending, thanks, Mail. The reason I'm sending this about Snowstorm Lite is you could follow along if you wanted. So this is an open source terminology server. It's kind of very small and lightweight and fast. It has restrictions. It can only host SNOMED CT content, but it can, do the special expansions like reference sets and ECL and all those things. But if you scroll down to near the bottom, we've got this link here, Postman, run in Postman. This is a link to the Postman collection that I'm using. And it's got all the Fire API stuff in it. So it's just another way of accessing the Fire API. So Postman's quite fun because you can switch between terminology servers. So in the Environments tab, I've got a local Snowstorm Lite running, which we can try. I've also got links to the international Snowstorm, which is not for production use, it's just for demonstration. But we can try it, and I've also got a link to eSante Fire API. So we can use any of those for any of these operations, really. So we could start by listing value sets, and I will start off against Isante, and I'm running that. And again, we get the same result. We get 266 for listing value sets. And this is what we did earlier. I can switch to my local Fire server and run the same operation again. The format's the same because it's the Fire standard. I've only got one value set in here. Let's look. I'm not actually sure how many are on the international server. Only 2. We don't usually publish many Fire value sets because we publish things using reference sets instead. But you can see that we can, using the same client and the same API call, we can just switch the servers and, things kind of work the same. I wanted to show some examples of creating value sets. Now, I know we talked at the beginning about the recommended architecture, and not having a single point of failure in the middle and having a local terminology server that you can access, which may give results faster, and you don't have so much internet connectivity problems. So it's a nice idea to take the resources from your national server and put them in a terminology server in your local infrastructure. And that's kind of why I'm just touching on creating value sets here. And specifically SNOMED value sets. So there's kind of 2 ways of creating SNOMED value sets. We always do it through like a post operation to value set. That's kind of a standard API thing to do. But the way we list the codes can be done in 2 different ways. We can either say I want to include these codes from SNOMED CT and these concept codes and list out each code. In this example, we're listing out just a few that we've picked, and they're the sexes or kind of the genders that we want to record in our system. I'm gonna send this one now and create it. I've tried to run that against Isante and it's failed. I should be pointing at my local. Run it again. Okay, so I've got a created response. So listing the codes is one way. The other way is to use ECL. If I wanted to create a set of all chronic diseases, for example, I wouldn't want to list them all out because there are too many. So we can just run a query. So I've said, I've given a URL that I want to use to reference this value set when I do the expand later. I've given it a proper name and a version. And then in the compose section, we say what we want to include. We can also say what we want to exclude. In include, I'm saying from the SNOMED code system, I'm giving a filter, and the type of filter is a constraint, and the is this as all the descendants of chronic diseases. I'm going to create that one as well. And then when we list our value sets, we should see them. This is our sexes value set that we created using a list of codes. And this is our chronic diseases value set. I'm going to expand each one of those using the URL, expand value set. So we're doing value set $expand, and then in the URL inputting sex. And we've got back our small list of codes. And we can expand the other one, which is the big list, chronic diseases. Expand. So this one we've got 2,700 codes, and then we're coming back. You wouldn't obviously present 2,000 codes to the clinician. You'd use, your filter parameter. Ooh. And what we're going to put in here, heart or something. So when we filter by something like heart, we get a much smaller set. This is kind of just giving you practice at seeing how you can create value sets, how you can expand value sets, how you can filter them. Hopefully it's useful. I'm going to move on from value sets now. We're going to take a quick look at maps. How are we doing for time? How long have I got left?
Doing well. It's 2 o'clock, so we have an hour left.
Great. All right. Don't need that. Let's look at maps. So this is about mapping between code systems. So you can link SNOMED CT to other code systems, or you may have a local code system, or maybe even a French code system that you're using, and you may want to, send concepts to another country or something else, and you may want to map to SNOMED, for example. There's many use cases for using maps. And one common use case that we see is that people are already using local codes, and they were trying to migrate to SNOMED CT. So they create a map between their local codes and SNOMED CT. They may keep the clinical phrases that they were already using, kind of as an interface terminology, something to show in the user interface. But behind the scenes, they're mapping to SNOMED so that they can, leverage the hierarchy and the reporting and the clinical decision support and everything else. And of course, a good use case for maps is communication of data between organizations. And sometimes maps are used just temporarily while migrating to SNOMED or to another code system. A really common use case, probably the most common use case of maps that we know, around the world is recording in SNOMED CT first and mapping to ICD-10, for statistical reporting to the World Health Organization. I think most of the clinicians we talk to like to record using SNOMED CT for conditions, procedures, medications, many other things. I know it's different between different countries, but of course there's a kind of global obligation to do some reporting using ICD-10 for statistical analysis. So here's an example of a kind of really basic map, and what it could look like in a kind of Excel format. So in the SNOMED release files, they're kind of tab separated values, and we distribute a map from SNOMED CT to ICDO, which isn't used so much anymore, but it's an example. And in the reference set field, we've got the reference set ID that identifies the map. Then we have a column of the SNOMED code, and we have a column of the ICDO codes. So it's kind of, this SNOMED code is this ICDO code, and, it goes on and on. So that's how the data is kind of published. There's other maps which are a bit more complex. And one example is the SNOMED CT to ICD-10 map. And that's an extended map because it's not just a pair of codes. There can be different things going on. There can be some map rules as well. So an example is the mapping between this code for infertile in SNOMED. In ICD-10, there's 2 different codes for infertility. There's this one for female infertility and a different one for male infertility. So when we publish this map, we actually produce some rules to say, if you've recorded this code of infertile, you need to check whether the patient is male or female during the mapping. Or maybe we give you, both codes and you kind of need to choose. You can automate this if you know the genders. So how do we do this in FHIR? We use the concept map resource, of course. We use the translate operation. And again, it's a standard format. We use the resource name, concept map, and a slash and a dollar, and the operation name of translate. And then we give various parameters. So the required parameters are the code that you're mapping from and the system that you're mapping from, which is SNOMED. In this example, we've also given a version, a specific version. We want to use the French edition. And we need to say the target system, where we're mapping to. And this is the URI to identify ICD-10. Let's run this one. I'm just going to run it in the browser. I'm going to run it against the international terminology server because I know it will work. I'll paste this in the chat if I can find it. Except translate example. Okay, so in the response, we get the first thing we get is a result. It's possible that no map exists to this code system, or the concept that we want to map isn't in the map. It might not be in there. And if that happens and the map translate fails, then the result will be false. For this code, it is in the map, so we've got a result of true. And for our SNOMED to ICD-10 map, it's kind of exhaustive. Everything that can be mapped has been mapped, and it's updated every month. And then in the response, we get some information about the match, and we've got a concept with a value coding. So the code system that we've mapped to is ICD-10, and the code is here. I don't actually know what this concept is. Let's go and have a look. I'm going to look it up in the browser. I still don't know what it is. It's female expansive osteolysis. No idea. Something to do with a disorder of the bones. I think it's some sort of rare disease. And in ICD-10 code, I looked this up earlier. Okay, so in ICD-10, it's a bit vague. It just says it's an other congenital malformation of the skeleton. So it's something gone wrong with the bones. Okay, so that's an example of using a concept map and using the translate operation. Is there any questions before I move on? We've covered co-systems and listing co-systems. We've covered value sets, listing them, creating them, expanding them, filtering them. We've covered concept maps. We haven't covered creating concept maps. It's possible, but there's a few published within SNOMED like this one. We've covered translating, like using concept maps. Is there any questions before I move on? They're all very quiet. No, fine. I'll keep going. So let's think more about, we've kind of gone, we talked at the beginning about like very broad high-level architecture. Then we dive down into using the APIs and what each of the API operations do, and giving us a bit of practice. Now let's step back again and talk about some of the use cases of the FHIR API. So Anna was talking at the start about information models, and there's different types of information models. Some of them are used to store data in an EHR. And we've kind of got that use case represented here, where you could have, for the data entry use case into an EHR, the EHR may not use fire like records or fire resources to store clinical information, but you still need to have some information model. You still need to have fields that are bound to a subset of codes, and you could use terminology services for that. So you could use a fire terminology server just to constrain the inputs into an EHR system, even if the EHR system doesn't use fire. So that's kind of one use case for the terminology module of the Fire API. You could define a value set for terminology binding in your EHR information model. The other one that is kind of easier, to think about and kind of the hot topic is about using the Fire standard and the Fire medication resources. And it's common when you're, implementing that standard to have an implementation guide, a Fire implementation guide, and we'll look at some examples in a minute. And those implementation guides lay out which information models you have, like which clinical resources you're going to create. And for each field, well, for the codable concept fields, they're often bound to a code system and a value set. So these are kind of two main use cases for Fire terminology servers. And it could be a national server, it could be a regional server, and it could be, any kind of vendor solution, whether it's open source or proprietary or something else. Concept maps is the other one. So concept maps could be used to transform between the codes used in the EHR and the codes used in the Fire standard for interoperability purposes. Some maps can be used in both directions, but not all maps can. Some maps can only be used in one direction, so it's something to be careful of. So there's some good examples. Let's take a look at some Fire implementation guides. And they give examples of bindings. So this is an example of a medication request resource. Before I talk through this one, I'm going to show how to actually find it. I think I'm still showing my whole screen. Yeah, I am. If you Google for like Fire, probably just Fire actually. Wow, that's a bookmark. That doesn't help. You should find fairly near the top, fire.org or build.fire. I usually search for Fire R4. Okay, this is good. Somewhere you'll find the Fire, the broad Fire implementation guide. So there's an international Fire standard, which is quite broad, and the terminology bindings are kind of just suggestions. And then you'll usually have a national Fire guide, which tightens up, the information models and tightens up the value sets and the terminology bindings. We're going to start looking at the kind of very high level, the international Fire specification. We've talked through today mostly about this terminology module, which specifies, what resources are available and how to interact with them. Down here, we've got the clinical resources. So this is how, at the international level, they suggest that you can record things like allergies, medical problems, procedures, observations, medications. And in many of these, at the international level, there's a really good introduction on all this content. But eventually we'll get down to the structure of the resource, this allergy resource. And there's many different fields, but in most of these resources you have a code somewhere, a code field with a codable concept. And when you have a codable concept, this is where you'd put in, you'd capture your terminology content, whether it was LOINC or ICD or MPU or SNOMED or something else. When we get to this level of code and codable concept, it will give an introduction to the codable concepts, the value set that can be used for this field. So this is terminology binding, we're specifying a value set for a specific field in an information model. And here in the brackets, it will say how strong the kind of recommendation is. This one's just an example, and most of them in the international guide for fire are just examples. And in this example, they're saying for the allergy intolerance code, it could be any of these SNOMED codes. So these are substances that someone could be allergic to or have an allergy to. And we can have a look at how this value set is defined. It might look familiar to you. No, I've gone the wrong way. Quickly going backwards. Where's the definition? Import all the codes that are contained in the substance code. Okay. I'm trying to follow my nose here. So this value set contains 2,000 codes that are within SNOMED CT. I'm looking for the JSON representation. Is it here? Yeah, okay, it's here. I'm looking for the raw JSON. Okay, here we go. So this is how this value set is defined. And a lot of this will be familiar to you now. We've got the URL of the value set, which we'll use if we wanted to do an expand. And down here, eventually, we've got the compose section. And if you look at the international level, the suggestion for the set of substances actually uses a filter on SNOMED content, and it says include all the concepts below this concept and all the concepts below this concept. We don't know what they are. We can look in the browser. One of them substances, so all the substances in SNOMED. I wonder what the other one is. No idea. Okay, pharmaceutical biological product. So this is kind of drugs. So you could be allergic to a substance, or you could be allergic to a drug. So that's an example of a value set that's used within a fire implementation guide. You remember I said that there's kind of a strength of recommendation. This one's example, so you could use it, you might not, that's up to you. I think there's another one in this presentation. Yeah, here, okay. So in this example of the IPS, and this is a medication request resource, it's not allergies, so it's a different information model. But they've specified a binding here for the medication code. So this is like the drug that's being requested. And they've got a binding to the medications in SNOMED CT, plus some unknown values if they don't know the answer. And here they're specifying that these are candidates. They kind of hasn't, either of these could be used essentially. For this field, that's also a codable concept. They've specified another binding, which is a small set of concepts. And again, they've specified the strength of recommendation. They're saying that this set is preferred. Probably once you get down to a national level, you'll have much stricter bindings where you have to use a specific value set. Again, this is just illustrating the same information. We've got the binding strength in brackets. We've got some additional bindings that can be used. Okay. There's a few other resources associated with medication requests. Okay, I don't think that's very interesting. Okay, there's like a formal documentation around these binding strengths. So as I said, at the international level, there are often examples. And then for the IPS, the International Patient Summary, which is a little bit tighter in context, they've got kind of preferred binding strengths. And then the other two that you'll see commonly, probably in your national specifications, like your specifications for France, you'll see required, and there'll be a set that you have to use. Sometimes you see extensible. This is where a set has been given to you that you have to use, but you could use, some additional codes if you need to. So that's binding strengths. There's also primary and additional bindings. I don't have any examples of those. Okay, so this is what the resource would actually look like once it's been created. We were looking at the specification for those resources, and this is an example of when a condition resource has actually been created, and we've got the fire resource created for a specific condition for a specific patient. So when we look at a fire resource, it always says the resource type at the top. And when we looked at the code systems and the value sets and the concept maps, they kind of followed a similar format. They said the resource type at the top. So this one's a medical resource. It's a condition. It always has a unique identifier. Sometimes it will have some text, explaining it. We've got various fields like clinical status, verification status, and down here we've got the code and the coding. So this is an example where we've got multiple codings. So you don't just have to record one code. When you've got a coding element, it actually allows you to record, one or more codes. So here we've got a primary binding and an additional binding. So the primary binding in the implementation guide for this resource was to use ICD-10. So you have to use, in this implementation guide, you have to record an ICD-10 code, which has been done, and that's first in the coding. But the implementation guide said you can also, if you want, to record a SNOMED code. So that's been recorded as well. And these are for different use cases. But it's nice that you can record both, and you specify the system. It's clear that this is an ICD-10 code and the display is given. It's clear that this is a SNOMED code. In this example, I think this is a made-up version, and we've got the SNOMED code there. So you don't always have to, choose a code system and always stick to it for certain fields, based on what the implementation guide is telling you. Okay. Still no questions yet. I'm going to come out a minute. How many slides have we got left? How are we doing for time, Anna? Can't remember when we finish. We've got half an hour left, I think.
Yeah, with time for discussions. But if there are no questions, then
it'd be great. Yeah. It'd be great to have some questions, I think. But I've got a couple more slides about interoperability, which I'll go through. There's only a few here, but please think of some questions for the end. So when you look at the definition of interoperability from the HIMSS website, they define interoperability as the ability of different information systems to exchange and integrate cooperatively use data in a coordinated manner. So exchange means, send or receive data, and integrate means understand the received data. So it's not always just a case of sending the data that you've got and hoping that the person at the other end can understand it. Because integrating and being able to understanding data that you receive and that data you send to others that they receive, understanding it is obviously really essential. So there's a few things to think about in the context of interoperability. When we're exchanging fire resources between hospitals or between countries, there's kind of a bit of logic to go through. So you can ask the question, do I have a code in this resource that complies with the primary binding of the implementation guide? I know in the example we just had, it was ICD-10 code. And if you don't, if it's no, then try to use a map to, to the required binding. So in our example before, maybe we recorded a SNOMED code, and that was kind of the additional binding, but we haven't satisfied the primary binding, like the ICD-10 code. So in that example, we could have used the translate operation to map to ICD-10 and add that ICD-10 code into the coding so that we can satisfy the primary binding of the implementation guide. And then once that resource is complete, then it's ready to send out to another system. So we can add multiple codings into a codable concept to help the receiving system understand. In another example, this is a real SNOMED example. And in SNOMED, of course, we have the international edition, which is accessible to all the member countries. We also have many, member national extensions of SNOMED or different versions of SNOMED. For example, in Argentina, they've got many new SNOMED codes which aren't in the international edition. There's a final sort of category of SNOMED, a different SNOMED code system, and that's the SNOMED IPS. This is a set of concepts which don't require the country to be a member of SNOMED. There are a set of concepts that are used for the international patient summary, where any country can use those SNOMED codes and send and receive them and understand them. So depending on who you're in terms of international interoperability, depending on who you're sending your fire resources to, you might prepare them in different ways. So let's try and follow the logic. Do I have other standard codes? I think that means, are we in Argentina, for example, and we've recorded codes which are only available in the Argentinian version of SNOMED? If it is part of the national extension, then we should use like translate or expand, use the terminology server to translate the Argentinian codes into the international edition. And we can do that by walking up a few levels in the hierarchy. Because SNOMED has like a meaning-based hierarchy, whenever you pick a very specific code, like a condition or a procedure or a medication, you can always walk up the hierarchy, like look at the parent code. And although that parent concept will be less specific, it will still be a good representation of what you're trying to record. So in this example, if we've recorded an Argentinian code and we want to send say, to France, for example, it's recommended to, walk up the hierarchy to the first international concept and also add that code into the coding or the codable concept element. So then the receiver has both the original code and the international code that they're more likely to be able to understand. There's other this flow is about receiving file resources rather than sending them. So when you receive a file resource, you could look through the codings, and you should use the validate or the lookup operations in your terminology server. And if you can validate them or look them up, then they're ready to import into your system, into your clinical repository. They may go through a manual clinical user validation process if they've been received from a different country. And then finally they can get into the clinical repository. If they don't validate, say they're not in your value set or they're not in the code system that you have, you could look for codings that can map. Okay, you could try to identify a map essentially, and then use the translate operation to map to your code system or your value set. And then this follows on. If you can't identify any map that you can use, then you can only use the visual information. So when you receive file resources, as well as the codes, you should also get the terms, a display term. And as a last resort, the display terms can be used, and then you have a manual job to kind of recode that file resource using your local codes, just based on the descriptions available here. So there's 3 ways of receiving file resources, probably from another country or from another group of hospitals. So there's a lot to think about, certainly, but there's a few mechanisms there to overcome interoperability. We've got a kind of summary of some of the things that you could look into if you want to learn more about SNOMED CT. We've got a short link here to the expression constraint language, or the SNOMED query language. I think I said in the chat, section 6 is the best to look at because it has loads of examples of what you can do with ECL. We've got a guide about using data analytics with SNOMED CT. And as well as a guide, we have an open source analytics tool here. It's available on GitHub. We've got the MRCM browser. We haven't really talked about that, Anna. We could touch on it if there's no other questions. And finally, we've got the terminology services guide here. There's a short link, TSG, terminology services guide. Yeah. Over to you guys. What questions do you have? Stunned silence.
Si vous avez des questions, n'hésitez pas à les poser dans le chat, et on peut aussi, si vous préférez le faire oralement, vous donner la parole.
You're also welcome to raise your questions in French, and Maëlle and Elizabeth can help us.
Kai, I have a question regarding the update of, for example, of subsets, or how if I use some SNOMED CT codes, can I be sure they are always updated, or they aren't retired? To be sure that my all the electronic health records I am managing are updated and are without any inconsistencies.
Yeah, okay. So over time, it's possible that SNOMED code might be retired, and sometimes they are retired. The majority of them are not, but sometimes they are. And that's really to reflect the evolution of, clinical knowledge, and what's most appropriate. So if you have used some codes in your clinical records that have become inactive, then those codes, should stay there. You keep the original code that you've recorded. But in terms of interoperability and reporting and analytics, especially if you're using the SNOMED hierarchy for, selecting relevant clinical resources. One thing to note is that using the intentional value sets, where you use like a SNOMED query, like is a type of asthma or is a surgical procedure. They all use the hierarchy, and if a code becomes inactive or gets retired, that code will no longer be part of the hierarchy. So I think there's two use cases for data input. When you're capturing new clinical information, you should always use concepts that are active today and are part of the hierarchy. But if you're doing, particularly if you're doing research, or if you're trying to find relevant, patients, then those codes might not be in the hierarchy, and you might miss those patients essentially. So we have a mechanism for also including inactive codes.
I found the slides. Should I show it?
Yeah, please.
Okay.
I found it in the ECL guide, but if you've got slides, that's even better.
I have slides here.
Yeah, go for it.
Do you see my screen?
Yeah.
Yes.
Okay. Yeah. So we were touching on this earlier as well, that SNOMED CT is constantly evolving, and things may be inactivated, as Kai said, but we do support the full traceability, and you can be rest assured that even though you have used a concept that may be inactivated, then you can still reason over it. And I just want to show an example. So imagine that you have this patient here that was diagnosed with hay asthma in 2005. And then in 2011, that concept was actually inactivated. Similarly, with this patient here, who was diagnosed with Baker's asthma, recorded in 2009, that concept is still active. And this patient with acute asthma, which was recorded in 10, but that concept was inactive in 2021. And this allergic infective asthma was recorded in 18, but that concept was inactivated in 19. So how is it that we go about doing analytics over those concepts that are now inactive? Because if you have then a research project or someone wanting to do analytics and needing to identify patients who have been diagnosed with some kind of asthma over a set of years, and you run that ECL that we have been looking at that today as well, like give me anything that is a descendant of asthma. And I'm running that over the July 2022 edition. Well, in that case, I would only get this Baker's asthma in the results set, whereas these three would not be included because then they are now inactive. And that can pose a problem. However, our expression constraint language have this feature, which we call history supplements, where you can indicate in the ECL that you also want to include the historical data. So including those concepts that when they were active, they were subtypes of asthma, because that would then include all of them. And the way that it works, because as Kai said, when we inactivate a concept, well, the identifier will be retained, but we will simply pull it out of the hierarchy. It doesn't belong there anymore. So it has no parents, it has no children, it has no attributes. It's simply an identifier with descriptions. We need the descriptions to be able to understand what we called it when it was active. Then what we do every time an author at SNOMED International inactivates a concept, they state a reason for why that concept was inactivated. For example, whether it was duplicate, ambiguous, or another one could be erroneous. There can be some error in it. But this inactivation reason will say something about how we can replace that concept. So for example, acute asthma was inactivated because it was found duplicate. So there is another concept in SNOMED with the exact same meaning. And in SNOMED CT, we shouldn't have any duplicates. So that was inactivated. But then aside from just stating the reason for inactivation, we also pointed to the active replacement. In this case, this concept. Similarly with hay asthma, which was duplicate, has the same as to hay fever with asthma. Then we had one concept here that was ambiguous, and then we pointed to a possibly equivalent to concept, which is active. But because it was ambiguous, we now know that there is something in this one that may not be covered in this other one. So sometimes you would have two or more associations to active concepts when we have an ambiguous concept. But we do that every time a concept is inactivated. We state why it was inactivated and then point it to a possible replacement. And these possible replacements are descendants of asthma. So when we now use the history supplement in our ECL, it will say, give me anything that is a descendant of asthma. That will include these, all the yellow ones here, and this one. And then because we have the plus history supplement, it will go through these historical associations and find anything that was inactivated. So that's why when we run those ECLs, all of them will be included.
So depending on what you're doing, if you're specifying a value set for data input, then you don't need to use the history supplement. But if you're specifying a value set for clinical decision support or reporting, or maybe validation of codes that you're receiving, then it makes sense to include the history supplement. And there's one more thing that we can do in Fire with inactive code, since we're talking about it. I'll share a window here. I'm going back to the postman, and I'm going back to the collection of the snowstorm light operations, and these operations should work the same on your national terminology server. But I'm pointing at my local snowstorm instance, and we've got a special map. This map allows us to translate from a code that's inactive to a code that's active. Again, using the historical associations, they're built into SNOMED. We can say, I want to do a map, I want to translate. I've got this code that's inactive. We should look at an inactive code first, actually. Let's look at that just briefly. If I do a lookup of a code, let's say it's this code, which I know is inactive. It's hay asthma that Anna showed before. We know it's inactive because if we go down, we've got an inactive property and the value is true. It's inactive. The code's inactive. So what we can do, so usually if we've got a value set of asthma that uses the hierarchy, and we use the validate operation, it will say it doesn't validate because it's no longer in the hierarchy. But we've got a translate operation that we can do. So we could take the inactive code, and it's in SNOMED, and we've got a few of these special maps that map from inactive code to active codes, and we can run that. And here we go. We've got an equivalent concept. Well, first of all, we've got a match, and we've got an equivalent concept, and the concept is this code, hay fever with asthma. I think it was called hay asthma, which was quite ambiguous, and people didn't know what it was. This is actually hay fever with asthma. So this is the code that you should be using. So yeah, there's a few ways around this code concept inactivation thing.
I think it's worthwhile just mentioning that it may seem like, well, that's a lot of effort and stuff, but we have actually done we've represented in a way where the services that Kai shows you can just be set up so that you make sure that you act with SNOMED CT properly. You don't have to make a lot of changes every time. It's more in the design phase and the setting up of your system. You need to make sure what are the kinds of services you need to use for what.
SNOMED's becoming a lot more stable now. I think some of those codes were from kind of 10 years ago, and we've had a quality improvement project running for about the last 5 years. So we're clearing up a lot of these inconsistencies, duplicates, where the concepts are ambiguous. And the reason we're doing all this work and cleaning up the hierarchy is because people are really using SNOMED now. They're using it in AI systems, they're using it in analytics, they're using it in reporting really heavily, and they're noticing this concept's ambiguous. These things are inconsistent. Can you improve the quality? So yeah, that's what we're doing, and that's why we're having these inactivations. But I think we're getting to a point now with the international edition that the quality is good. It's much higher and more reliable. So the number of inactivations is going down. It was quite worrying when we saw Anna's screen. She showed 4 versions of asthma, and 3 of them were inactive. But yeah,
I designed that example, right?
It's not as bad
I
as
was
it looks.
telling a story.
There's a question in the chat.
Yeah.
Does the value set expansion mean we copy the data to our terminology server? Is there some out-of-the-box routine to synchronize the national, international terminology server with the regional? Yes, that's a really, really good question. Thank you. So there's 2 parts to that question, isn't there? The first part is, if you're doing it manually, what's the best way to do it? If you're doing it manually, it's best to look at the value set itself, not the expansion, because the value set itself will show the compose section and the include sections. And sometimes they list codes, but sometimes they have like a query, like all the descendants of this concept. Let's show an example. So that's what you should copy into your terminology server. I'll share my whole screen. So when we list value sets, say you wanted to look at your national terminology server, you wanted to list the value sets, and you wanted to, for your local system, you wanted to use a local terminology server, like one in your group of hospitals. So you could create a new instance of Snowstorm, for example, or any fire terminology server you want. And I guess you could have a script that goes and lists the value sets, and then for each value set, you can take the URL, and you can look at one single value set. I'm trying to. We don't have an example of looking at a specific value set in here. I'll add that. The way you do it is you say question mark URL equals this. I think. No, it isn't. Okay, you can use the full URL. That's one way. Basically, you want to look at the single value set. So then you should get a resource type, which is a value set. Okay, so we're not doing the expand. We're just looking at the resource itself. And this will include the compose and the includes. And here we've got some queries, for example, descendants of this concept. So if you take all of this information, that's the best way to copy the value set. So you're copying kind of the queries themselves, not the codes. So then you could use the create operation on your terminology server to recreate those value sets with the same URLs. And then you can expand them as well. So following this method, you would need to, import the code systems that you're expanding against. So you'd need to import, whether you're using Loink or some national code system or SNOMED or whatever else. The other part of the question was about, is there a synchronization method? We know that Onto server, which is the software used by your national terminology server, has this thing called syndication, and that's where it's possible to take the content from one server and put it onto the other. We're trying to develop at Snowden International a way to hook into the syndication kind of mechanism. We have agreed at the international level the format of the syndication and kind of the details of the protocol, but we're just at the stage of testing, taking the resources from Onto server, for example, or another national terminology server, and pulling it into Snowstorm Lite, or there's a full version of Snowstorm as well. We've asked other people to test this mechanism as well. I'm not sure if B2I with Snow Owl are working on it as well. I'm not sure. So at the moment, there's no automatic way apart from writing a script and kind of listing them and copying them one by one. But yeah, it's something that we're working on, and we realize that it's kind of a gap in the functionality. Definitely be nice to have that, I think.
Yes, and it is coming, right?
It's coming. Yep. Okay, great. Yeah, really nice question.
Je ne sais pas s'il y a d'autres questions ou besoin de précision. Comme le dit Anne, vous pouvez envoyer un email. Hein, Anne a mis l'adresse mail dans la conversation. Sinon, vous pouvez également nous joindre, Maëlle ou moi ou ANS Terminologie, @isanté.gouv.fr.
We hope that you enjoyed the presentations, and I hope that it gave you some food for thought, and that it matched what you were expecting. Yeah, as Elizabeth had to say, you can always reach out to us.
And thank you again, Anne and Kai, for your presence and all those presentations. It was really, really interesting, and I hope that we will have some feedback from the ecosystem or some question. So we'll keep in touch.
Sounds good.
Yeah, if anyone is interested in setting up their own terminology server and they would like to try out Snowstorm Lite or Snowstorm from Snowden International, please get in touch. As I said before, the Snowstorm Lite is a small, fast terminology server which allows SNOMED queries, but you can only host SNOMED. So I don't know, it's kind of limited use. Whereas the full Snowstorm requires a bit more memory. Kind of, you really need a server like 8 gig of RAM, but you can host any terminology in it. Loink, ICD-10, SNOMED, multiple versions of SNOMED, multiple releases, or any other terminology. There's quite a few small code systems that are baked into the HL7 Fire standard. Small codes for like statuses and things like that. Those can all be imported into Snowstorm too. So yeah.
Thank you very, very much, Anne and Kai, and merci beaucoup à tous. On va s'arrêter donc, et puis très très bonne fin d'après-midi, et surtout n'hésitez pas Si vous avez des questions, des demandes, à revenir vers nous. Merci beaucoup. Au revoir.
Au revoir.
Merci beaucoup. Au revoir.
Au revoir.
Merci, au revoir.